This is a good question from Nuclei. Assume that the nuclear binding energy per nucleon B by A versus mass number A is as shown in figure. Use the correct plot to mark the choice given below. So there is a graph given of binding energy versus A. You need to find out the which of these is correct. So for the first one, fusion of two nuclei with mass number lying in the range something given 1A to 50. So I'll be solving this. Let's assume you are taking two nuclei at this position. So one nuclei having mass number 40, another nuclei having mass number 50. So 40 into 2 plus 50 into 2 is their combined binding energy. That will be how much? 40 to the 80 plus 50 to the 100, 180. But they are making a nucleus as 40 and 50. When they will fuse, they will make a nucleus of mass number 90, and mass number 90 binding energy is also 2. So again 90 into 2 will be 180. So whatever the binding energy of the reactant, that is the binding energy of the product. So that's clearly indicate that that will not release any energy. So this option will not be correct. Now the second option, fusion of two nuclei, mass number lying in the range 51 to A to 100. So for the second option, I will be doing for 51 to A to 100. So I am taking 60 and so let's say I am taking 60 and another one I am taking 90. So 60 into 2 is 120 binding energy, 90 into 2 is 180. So total is 300, and they make an atom which is they make a nuclei which is having mass number 60 plus 90, 150, and for 150 the binding energy is 8. So 150 into 8 will be how much? 1200. So initial energy is 300 and now the energy is 1200. As the binding energy increased, so energy will be released. So this option is correct. And for the next two option, fusion of nucleus lying between 100 to 200. 100 to 200 you can say that 150. So 150 have a binding energy 1200. When they, let's say 150 break into two fragments, 60 and 90. 60 and 90 both whenever they will be separated, they will be having binding energy 300. So binding energy decreases. That means they will never release any energy. You need to provide energy to break into fragments. So this option is also not correct, because this has been told that this will release energy. This will never release energy. This you need to give energy from outside to make it happen. That two of the nuclei will going through the nuclei will going through a fusion. Next, the last one is 100 to 260. For 100 to 260, let's assume 200 or 200. Let's assume 200, or let's say 220. So for 220 into 4, that means 880 is binding energy. Let it break into fragment, like one is 140, one is 80. So 140 into 8, 140 into 8 is how much? 1120. And for 80 into 2, that is 160. So it is having energy 1280. So in this case the binding energy is also increasing. So in this case energy release. But if you take a nucleus like let's say 120, so in that case what will happen? 120 can be broken into fragment 80 and 40. So 120 into energy is 8, that is 960, and 80 into energy is 2. 80 into 2 160, and 40 into 2, that's also 80. So now in this case the binding energy decreases. So option D will not always happen. Sometime it may release energy, sometime it may not release energy. So that's why option B will be your correct answer.